on the GoToWebinar control panel to allow all attendees to hear you. This system will notify you once you begin your broadcast. The broadcast is now starting. All attendees are in listen-only mode.
Good morning to everyone. We're going to start today's session. So in today's session, we're going to see how to use SQL Script for SAP HANA. First, we're going to start with C functions. Okay, so let me log into HANA Studio. Let us expand content. In content, we have a package called HDB. HDB is the name of the package. So if we expand the HDB package, under HDB you find another HDB. In here you find a package called SQL1. Expand this package. So here you find C functions. So what is C function? Calculation views we create in SAP HANA. Which engine does they execute? They execute on C engine. When SAP released initially, SAP recommended to use C functions to create SQL script calculation views. C functions are optimized to execute in C engine, nothing but the calculation engine. But however, from HANA SP7, even the SQL engine, you see, SQL engine is nothing but the calculation view of type star join is designed to execute on SQL engine. Has become stronger in SAP HANA. And we also have an option whether to go for a C engine or an SQL engine when we execute in C functions. So C functions are categorized into three types in SAP HANA. So in order to know, when you want to execute on C engine, they're categorized into three types. One is known as data source access operators. Data source access operator. So data source access operators are used to read data from either column tables or SAP HANA modeling views. You can use these operators to read from column tables or SAP HANA modeling views. Next one is relational operators. So relational operators, these are used to join different data sets. You also have something called special operators. So these are used for specific operations like currency conversions and unit of measures. Now first let us start with data source access operators. So data source access operators have four different functions. Data source access operators have four different functions. First one is C underscore column underscore table. So what is the use of this function? This function is used to read data from a column table. C underscore column underscore table. Just table. Just you can remember table, column, C. C is the engine. Table in columnar fashion. C underscore column underscore table. So what is this used for? To read data from column table. So what is the syntax? Syntax is C underscore column underscore table. Give the table name. And the column names, nothing but the projection of columns. Give the attributes. So let us see one example based on this. So here I created one example for C underscore column underscore table. So this is the example. So this is the syntax: C underscore column underscore table with table name and the attribute name. So this is the projection. Double click on the calculation view. So here you would see script view. Click on script view. So here you have a simple statement where underscore out is equal to C underscore column underscore table schema dot table comma projection KNDNR, ARTNR, VV010 and VV010. So these are the three columns in the output. KNDNR, ARTNR, VV010. Let us click data preview. Click raw data. So this is the data output. So we'll create our own view now. We'll create our own view. Right click on the package, click new, click on the calculation view, CV underscore C underscore column underscore table, calculation view type, select SQL Script and click finish. So once we finish, here you would see, the SQL script. So here you would see the SQL script and the semantics. So first we need to define the structure of the calculation view. So what are the required outputs? We need to select the structure. And once we select the structure, then we need to give the statement. We need to provide the statement for the view. So let us first create the structure for the view. Click script view. We are in the details pane. Now here we see the output pane. So here you see the plus icon. Click new. Click create columns. Give the output columns KNDNR, ARTNR, VV010, nvarchar, nvarchar. So KNDNR, the length of the customer is 10. Material. Length of the material is 18. VV010. Decimal. Length is 15 and scaling and decimal scaling factor is 2. So we have given the output and click OK. So this is the expected output. Now in the details pane, we need to give the statement here. So here we require var out. So what is the syntax? C underscore column underscore table schema name and the table name. What we can do is we can just go to the catalog, expand the catalog, go to any of the schema that you already know the tables are available. So let's see ECCSLT 009. Don't have. I'm just looking for a C1 idea table. Okay, let us take this table. So select and drag and drop this table onto the scripted view. Select and drag and drop. Comma. Now let us do selection of columns. So what columns we require? K and DNR. ARTNR. BV010. So this is the syntax, and based on the syntax, table name, attribute name, we have given this. So once you define the syntax based on the required output, click save and validate. So now these columns are available in the semantics. You see here, all these columns are available in the semantics. Click on save and validate and click on save and activate. And select the package and click finish. So once we click finish, completed successfully. Let us go to the calculation view package. So here is C underscore column underscore table. Just right click on this. So this is the name of the view and data preview. And click raw data. So in this way, based on the calculation views, using C functions, you can call data from a table. So let us see the next one. So this is a simple statement to call a column table inside SAP HANA. Let us see the next one. So the next operator C underscore join underscore view. C underscore join underscore. So what is the use of this function? The use of C underscore join underscore function is it is used to call attribute views. I'm sorry, I think it got muted. To read data from. So let's see the syntax for this. C underscore join underscore view column underscore view underscore name So here we're taking C underscore join underscore view, column underscore view underscore name, and the attributes. So let us see one example for C underscore join underscore view. So instead of a table, we are using a column view. So this is a C function. C underscore join underscore view underscore sys underscore BIC. This is the column view, and this is the projection. So like that, this is you're calling the table HANA user.c1IDA KNDNR VV010. So if you want to call NLT view, it is C underscore OLAP underscore view. To call a view of attribute view C underscore join underscore view, to call an NLT view C underscore OLAP underscore view, so for a OLAP view, everything is same. The syntax, everything is same, but it has measures. So OLAP underscore view underscore name attributes and give the aggregation type and provide the measures. This is for NLT view. So in the NLT view, you have 4 different aggregation types. One is sum. Yesterday we see sum is to sum, mini is to get minimum value, maximum is to get maximum value, count is to get count of values. So we can use here sum column slash count column to calculate average. So sum column by count of columns to calculate the average. So just like join view, we can use OLAP view. Let me show you an example for OLAP view. Nothing is different, same, just a C function is changed. Instead of C underscore column underscore table, we use C underscore OLAP underscore view, sys BIC, package name, table name, and the column names to the output. The last data access operator is C underscore CALC underscore view. So this is used to read data. This is used to read data from calculation view. This is used to read data from a calculation view. Same syntax. So instead of OLAP, we use calculation. C underscore CLC underscore view. So there are four. One is C underscore join underscore view to read data from attribute view. C underscore OLAP underscore view to read data from analytic view. C underscore calculation underscore view to read data from calculation view. C underscore column underscore table to read data from column tables. So in real projects, if you ask me, we use very minimum because graphical engines are very powerful than C engines. But still this is important in terms from certification point of view. From certification point of view, you're going to get 5 to 6 questions. But in the real usage in project, it is very less because SQL engine is more powerful than C engine. We rarely use them, but still for writing the exam, this is important. So in exam, they're going to ask us, what is the importance of C join view, OLAP view, calculation view, or a column table? To clear those questions, this is important. Next we see relational operators. Relational operators. So there are 7 different functions in this category. First one, C underscore join. This function is used to perform inner join between two sources and to read the required columns and data. So what is use of C join? It's used to perform inner join to read data from two different sources and to read the required columns and data. The syntax is C underscore join left table comma right table comma join attributes. So these are the tables. Next is we need to join these attributes. Comma. Finally is projection. Columns underscore list. So let us see the example of C join. C join Let us try to understand this statement. So here you have begin. T1 is a variable. So T1 is a variable. C underscore join underscore view is the data access operator. So here the schema, we're calling the attribute view called AT customer. And this is the projection, KUNNR and name 1. T2. In T2, we're calling the table C underscore column underscore table, schema, table name, and these are the projection of columns. T3, C underscore projection. So why are we doing projection? We're doing projection because you see KUNNR and KNDNR has different technical names. Just trying to convert to a common technical name. That's why we are using C projection. C projection here. So we are declaring T2. In T2, KNDNR as KUNNR. And finally, in where out, in the output, C underscore join T1 T3, which we rename now, which we rename KNDNR as KUNNR T3. So these are the variables. So we join on KUNNR, join on KUNNR, and this is the output. So C join T1 table name, left table, right table, join on a common key. So what join does it execute when join on a common key? Inner join. Left table, right table, join attributes. So it default executes inner join, and this is the output of the columns. So here we can modify the view according to our requirement. For example, you can change this, whatever the code you want to change, you can change this. You can copy this and you can change. When you want to practice, you can copy and you can change. So let's validate and click save and activate. Completed successfully. Click on semantics. Click data preview and click on raw data. So here we see customer, customer name, and the gross revenue based on customers. So this is C underscore join. Next, A second one, C underscore left outer join. So what is the use of C underscore left outer join? This is used to perform left outer join between the sources and bring the required columns to output. Except the name of the function, the syntax is exactly same. There is no difference at all. Everything is same except the name of the function. Next, C underscore right underscore outer underscore join. This is used to perform right outer join between the sources and bring the required columns to output. Syntax is exactly same again, just we have to replace with C underscore right underscore outer underscore join. Next, C underscore projection. So just now we see here, in here we see the usage of projection here. So C underscore projection, variable T2, KNDNR as KUNR. Here we are using C projection to rename. So the function is used to pick specific columns from source and apply filters to restrict the data. Or we can also create alias of the column name. So this is known as alias column. So we can also perform alias the column name using this function. One of the use case for aliasing is when you want to perform join and column names are not same. You see in here column names are not same, but I want to perform a join. So that's why I'm using C projection here. So the syntax for this is C underscore projection, table name, table name, column name, comma filters. The last one is, the last but one is, fifth one is C underscore calculation. So what is the use of C underscore cal? This function is used to calculate additional columns. For calculating the additional columns, based on the business requirement. This is same as the calculated columns in the graphical models. In the graphical model, you see there is something called calculated column. So this is similar to calculated columns in the graphical model. Similar to graphical models. So this is the syntax. C underscore cal expression result underscore. For example, you want to calculate a new calculated column called net revenue. Sales reductions minus gross revenue. Gross revenue minus sales reductions will give the calculated column. So here you have the data model. So here you have C underscore CALC. See, we are writing the expression C underscore CALC VB010 minus VB070 decimal as net revenue. So in the output, we are deriving a new column called net revenue. So based on this, it's going to give the output. So this is the syntax. Next, C underscore aggregation. So this function is used to perform aggregation on certain columns based on grouping of columns. So the syntax is C underscore aggregation table underscore name aggregated columns, attributes, group by columns. So this is mainly to use sum, max, mini, count. So here you can see this in aggregation, C underscore aggregation. So this is aggregation, AGGREGATION. So here we are using C underscore rollup underscore view, package, column view. This is the projection of column, C underscore aggregation. We're using the variable count. So what are we trying to do? We're getting the count of K and DNR as NUMT, num customer. So to get the count for num customer, we're using C underscore aggregation. Next is C underscore C underscore union underscore all. In C underscore union underscore all, this function is used to combine more than one source with identical columns. This is same as union node in the graphical calculation view. It is used to combine more than one source with identical columns. So this is same as a union node in the calculation view. The simple syntax C underscore union underscore all source 1 comma source 2 . So let us see an example for C underscore union underscore all. C underscore union underscore all. So column table, C underscore column underscore table, KNDNR, ARTNR, VV01070. So this is the table. So this is the second column table, C underscore CE to IDA. And this is C1 IDA. Now we're doing projection on T2 because measures are different. Measure technical name is different. So we're trying to rename them as VV01, VV01, 0001 as VV010. BV07 0001 as VV070. So once we've done the projection, in the where out, we have C underscore union underscore all. In C underscore union underscore all, we have T1 and T3. These are the variables. This is a column table and C projection T3. So click data preview and click on raw data. So we're trying to use combine C1 and C2 IDA tables. Next we see special operators. What special operators we have inside the calculation view. So all these are relational operators. C underscore join to join tables, left outer join for left outer join, right outer join, selection of columns, aggregate columns, union columns, union different sources. So in special operators, you have C underscore conversion. So this function is used to apply for unit of conversion, whether it could be currency or unit of measure. For unit of conversion. Syntax C underscore conversion. Table underscore variable. Comma. Conversion underscore parameters. daemon underscore class so see this equivalent function for SQL is for converting the currency. Requires some of the currencies and unit of measures from ECC that are available in SAP HANA. When you want to do unit of measure conversions or currency conversions, like how we do in graphical user interface, it's similar to that is C conversion. Next is trace. This function is used for debugging when we have calculation views C functions in SAP HANA. The input can be one of the C function. This will capture the output and we can validate after we execute the calculation view. Syntax is so these are the different C functions in the calculation views of type scripted views you can create. So I've given different examples over here. You can go to the package HDB. Under HDB, you'll have another package called HDB. Then here you can see C underscore calculation, C underscore column, C underscore join, C underscore trace, C underscore union all, C underscore vertical union. So what is vertical union? This function is used to concatenate the columns from more than one source. So in vertical union, the number of columns from all the source need not be same, unlike C underscore union underscore all. And one important point for C vertical is the cardinality between the source should be same. Next we have C underscore aggregation. C underscore cal underscore view, column underscore table to join, to call attribute views, to call NLT views, to do union, to do a left outer join, for right outer join. So whenever we create a calculation views of type scripted views, when we data preview, click raw data, click on show log, double click on generated SQL. So these statements create a procedure in the database. So here you have, this is the name of the procedure. A scripted views create a procedure. Let's go to sys underscore BIC. Expand the catalog underscore sys underscore BIC. And I click on column views, filter, whole word, click OK. And then let's go to the procedure. What's the package name? HDB SQL1 C underscore join 9. For example, we see here HDB SQL1 C underscore join 9. Double click on this. So please see, when I create a scripted view of type calculation view, so here we can automatically system creates a procedure in the backend along with the calculation view. So you also have a decision table. So procedures are created by system. In the package, when right click new, here you have a decision table. So what is a decision table? In SAP HANA. So decision tables are used to write business rules. So for any requirement, for example, based on each sales order, you want to give discounts to customers based on each sales order. So different applications are used to build business rules for writing SQL procedures and to load result data. So decision tables are used to build business rules in SAP HANA. Just to create business rules, we use decision tables. Let us create one decision table. I'll click on decision table. DT underscore VBAK underscore sales. Let's give the description. Click finish. Let's give the table name and the data foundation VBAK. Let us select from I'm not sure whether which we have authorization for this. Selected VBAK. So I'm selecting VBLN and NETWR, net value of the sales document, as the attributes. I'll click on decision tables. So VBLN and NETWR, I'll click on decision table. So we take VBLN, add as a condition, and NETWR, add as an action. Now let us create parameters. Let me create a new parameter. data type decimal, length 15, scale as 3. Click OK. So I'll take the parameter as output. Right click, add as an action. I'm taking this as an action to the output. So in the decision table, in the decision table, I'll start to define the business rules. Then we don't have data in the table. We need to get the data for tables. Let me check which table has data. We also have in best schema. I'll use from best schema. So here I'm going to take VBLN and NATWR, net value with sales document. Before that, let me once check data in here. Data preview, click raw data. Yes, we have data in the table. So I'll take VBLN as a condition. I'll create a new parameter. So I'll take decimal, length 15, scale is 3, and click OK. So this I'll take in as an action, add as an action. So here you see this is the output value and this is the original value. So I'll also take this as action. So in the decision table, so here you can give the default value. So let's say 16858. What is the logic you want to apply? So here in ETWR into 10 NEWR into 10 divided by 100. So this is the first value. You can even upload. So who is going to give the business rules? So business can give, you can import data or you can export data. So you can add condition. You can add one more condition. 6872. So like this you can give. So business is going to give all the business rules. Based on the given business rules, we can create a decision table. Click validate and click save and activate. So just defining the business rules. We are defining the business rule given by business. Once done, expand the content. Right click on the catalog, refresh. So this decision table, which is dt underscore sales underscore data VBAK. Let's go to the schema underscore sys underscore BIC. Let's go to procedures, expand procedure, dt underscore sales underscore data. So here we see dt underscore sales underscore data underscore VBAK. So this also decision table creates a procedure. So I'm basically creating a graphical user interface. So I'm creating using a GUI, and system generates the SQL script for the given procedure. Create procedure sysbic where output return value VBLN as VBLN NEWR. Case when VBLN then NEWR. So everything is written by system. When you create a decision table, automatically the code is written by system and creates a procedure. So this use case, decision tables, in short, decision tables are used to build business rules easily in SAP HANA, can be used as source to build reporting models as well. You can also use these decision tables in data models. So you can update data for a specific columns by defining business rules. Decision tables with update value. So when you use decision tables with update value, you can update the values in the decision table. So we must have the modeling privilege. So when using decision tables, to activate the decision table, there is a schema in sys underscore repo underscore sys underscore repo. This requires the select privilege, execute privilege, and update privilege on the schema where the tables are residing. Sys underscore repo requires select, execute, and update privilege on the schema where the tables are residing. So just to recap today's session, and today we started with understanding data source access operators like column tables, C underscore column underscore table, join, overlap, C underscore calculation underscore view. All these are used to read data. And then we see relational operators like in C underscore join, C underscore left outer join, right outer join. You see most of them are similar. One is to read tables and views, the other one is to use operators, and the other one is to use the special operators like conversion, trace, vertical union. And then decision tables are used to create business rules based on the user requirement. It creates procedures. We can use decision tables even in reporting data models. So, any questions? Please ask me. So you can, for more information, you can refer to HA150. So HA150 has syntax, it has details of examples. HA150, you can refer to that. For anything related to SQL, please refer to HA150. So, like for HANA modeling, you have HA100, 300, 350, 900, like that. The book for anything related to SQL, just refer HA150. That's the best book. Thank you, everyone. We'll see you tomorrow. So tomorrow we can see the installation of SAP HANA, how we can start doing installation and administration. And later, from day after tomorrow, we start the certification questions. So we'll explain detailedly all the 1 to 120 to 150 questions. We can, from Wednesday, we can see all the certification related questions. So by next week, you're ready to write the exam. You can take it. Please take it, the exam. 100% you can clear, no doubt about it. Just you can go through all the videos once. Once you can go through all the videos and read the certification questions. Anyone writing the exam, you can take up the date, you can write the exam. Thank you, everyone. And the code for exam is 151. I know some participants are writing next week. They already informed me. We can discuss and close it off. Thank you. Thank you, everyone. I'll see you tomorrow, same time. Good morning and good night, everyone.